Jane Sara, a student of Korea College, taking up Bachelor of Secondary Education major in Mathematics. For this video, I will be having a presentation on Binomial Series. So, here we go! Binomial series is the Maclaurin series expansion of the function 1 plus x raised to k and written in a general form of 1 plus x raised to k equals to the summation of x raised to n as n goes from 0 to infinity and the index k to n where our index k to n equals k times k minus 1 k minus n plus 1 over n factorial, where n is greater than or equal to 1 and our index k to 0 should be equal to 1, which claim that if k is any real number and the absolute value of our x is less than 1, then 1 plus x raised to k equals to 1 plus kx plus k times k minus 1 over 2 factorial times x squared plus k times k minus 1 times k minus 2 over 3 factorial x times x cubed plus and so on. Well, actually, binomial series is similar to binomial theorem, except that it's an infinite series and we must have absolute value of our x should be less than 1 in order to get convergence. Now, let's take a look at some examples for further clarification and understanding of the topic. Okay. So, our first example, we have 1 plus 3x raised to negative 6. Now, we'll try to determine the first 5 terms of the given. But first, we need to make sure that it is in the proper form to use the binomial series, which is 1 plus x raised to k, which in this case, it is already in the proper form with the value of our k equals negative 6. Now, we'll need to plug this into the general form, which is the summation of x raised to n as n goes from 0 to infinity, index k to n. So, our k, we have to replace it into negative 6, and for our x, we have the value of 3x. Now, using the formula 1 plus kx plus k times k minus 1 times x squared over 2 factorial plus k times k minus 1 times k minus 2 x cubed over 3 factorial and so on, we have 1 plus the value of our k, we have negative 6, multiplied by the value of our x, we have 3x plus negative 6, and k minus 1, we have negative 6 minus 1, x squared, we have 3x squared, plus our k, negative 6, k minus 1, we have negative 6 minus 1, for k minus 2, we have negative 6 minus 2, over 3 factorial, and for our x cubed, we have 3x cubed. And for our k, we have negative 6, k minus 1, we have negative 6 minus 1, for the k minus 2, we have negative 6 minus 2, negative 6 minus 3 over 4 factorial, and 3x raised to the power of 4. Now we have 1, negative 6 multiplied by 3x, we have negative 18x, and negative 6 multiplied by negative 7 over 2 factorial, we have 3x squared, we have 9x squared, plus 3 plus negative 6 multiplied by negative 7 multiplied by negative 8 over 3 factorial times 27x cube 6 multiplied by negative 7 multiplied by negative 8 multiplied by negative 9, and for our x raised to 4, we have 81x raised to 4 over 4 factorial. Now we have 1 minus 18x, negative 6 multiplied by negative 7 over 2 factorial multiplied by 9x squared. We have positive 189x squared. And negative 6 multiplied by negative 7 and negative 8 over 3 factorial multiplied by 27x cubed. We have negative 1512x cubed plus negative 6 multiplied by negative 7 and negative 8 and negative 9 over 4 factorial multiplied by 81. We have 10,206x raised to 4 and so on. Therefore, the first 5 terms of this examples, we have 1 minus 18x plus 189x squared minus 1512x cubed plus 10,206x raised to 4 plus dot. Okay, got it? Now, how about this example? We have 1 minus x raised to 1/3. Notice that the given is not in the proper form, which is 1 plus x raised to k. So from this given, we have to make this into 1 plus open parenthesis negative x close parenthesis raised to 1/3. Now we already have it into the proper form, and the value of our k is 1/3. Now plug it into the general form. We have 1 plus negative x raised to 1/3. We have the summation of negative x raised to n, as n goes from 0 to infinity, and the key index k to n, we have to replace k into 1/3. Now, using the formula 1 plus kx plus k times k minus 1 over 2 factorial times x squared plus k times k minus 1 times k minus 2 over 3 factorial times x cubed, and so on. We have 1 plus the value of our k, we have 1/3, and our x, we have negative x plus 1/3 k minus 1, we have 1/3 minus 1 over 2 factorial and negative x squared plus 1/3 times 1/3 minus 1 times 1/3 minus 2 over 3 factorial multiplied by negative x cubed and dot. Now, we have 1/3 multiplied by negative x, we have negative 1/3 x. Now we have 1/3 multiplied by 1/3 minus 1 over 2 factorial times negative x squared. We have 1 over 9x squared. And for the fourth term, we have 5 over 81x cubed and so on. Therefore, the first 4 term of this second example is 1 minus 1/3 x minus 1 over 9x squared minus 5 over 81x cubed. How about this example? Now, for this example, write down the first 4 term in the binomial series for square root of 9 minus x. So, in this case, our k is equal to 1/2. And as what I said in the previous example, we have to make sure that it is in the proper form to use the binomial series. So in this case, we need to rewrite the term a little to put it into the required form. So let's do this. Now, from square root of 9 minus x, we'll need to transform it into the rational exponent. We have 9 minus x raised to 1/2 in order to have the form 1 plus x raised to k. So, now we're going to factor it out. So, we have 9 times 1 minus 1 over 9, x raised to 1 half. Now, how did this happen? Now, we'll try to multiply 9 times 1. So, we have 9. Multiply 9 into negative 1 over 9x. We have negative x. So, we 9 times 1 minus 1 over 9x raised to 1 half. Now, 9 raised to 1 half times 1 over 1 minus 1 over 9x raised to 1 half. We have 9 raised to 1 half, we have 3. And 1 plus negative 1 9x raised to 1 half. Now, it is already in the proper form. Then we'll need to plug it in the general form. We have 3 decimation of negative 1 over 9x raised to n, as n goes from 0 to infinity. And the index k to n will need to replace k by 1 half. So using the formula 1 plus kx plus k times k minus 1 over 2 factorial times x squared plus k times k plus 1 times k minus 1 rather times k minus 2 over 3 factorial multiplied by x cubed plus dot dot dot. Now we'll have 3 multiplied by 1 plus the value of our k, we have 1 half. Our x, we have negative 1 9x plus our k, we have 1 half times 1 half minus 1 over 2 factorial. Our x is negative 1 over 9x squared plus 1 half multiplied by 1 half minus 1. Multiply again by 1 half minus 2 over 3 factorial. Our x is negative 1 over 9x cubed plus and so on. Now copy the 3. We have 3 times 1 plus 1 half multiplied by negative 1 over 9x plus 1 half times negative 1 half over 2 factorial multiplied by 1 over 81x squared plus 1 half times negative 1 half times negative 3 over 2 over 3 factorial multiplied by negative 1 over 729 x cubed. Now copy the 3. We have 1 minus 1 over 18x minus 1 over 648x squared minus 1 over 11,664x cubed plus dot dot dot. And multiply it by 3. We have 3 minus 1 over 6x minus 1 over 216x squared minus 1 over 3,888x cubed plus dot dot dot. Therefore, the first term for this binomial series, we have 3 minus 1 over 6x minus 1 over 216x squared minus 1 over 3,888x cubed plus dot dot dot. Now, how about this example? We have the cube root of 8 minus 2x. Now, the same process for the previous example, we have 8 minus 2x raised to 1/3. And then, we have 8 raised to 1/3 multiplied by 1 minus 1/4 x raised to 1/3. 8 raised to 1/3, we have 2 multiplied by 1 plus negative 1/4 x raised to 1/3. So, it is already in the proper form. Now, we'll plug it into the general form. We have 2 the summation of negative 1 over 4x raised to n as n goes from 0 to infinity. Index k to n, we have our k, which is 1/3. Now, using the formula, 1 plus kx plus k times k minus 1 over 2 factorial times x squared plus k times k minus 1 times k minus 2 over 3 factorial times x cubes, and so on. Now, copy the 2. We have 2 multiplied by 1 plus the value of our k, we have 1/3. The value of our x, we have negative 1/4 x plus 1/3 times 1/3 minus 1 over 2 factorial multiplied by negative 1/4 x squared plus 1/3 multiplied by 1/3 minus 1, 1/3 multiply again by 1/3 minus 2 over 3 factorial multiplied by negative 1/4 x cubed plus dot dot dot. Now copy again number 2. Not 2. We have 2 multiplied by 1 plus negative 1 over 12x plus 1/3 multiplied by negative 2/3 over 2 factorial multiplied by negative 1/4 x squared plus 1/3 multiplied by negative 2/3 times negative 5 over 3 factorial times multiplied by negative 1 over 1/4 x cubed. So we have here 2 times 1 minus 1, 2 bracket 1 minus 1 over 12x minus 1 over 144x squared minus 5 over 5,184x cubed plus dot dot dot. Then multiply it. 2 times 1, we have 2. 2 times negative 1 over 12x, we have negative 1 over 6x. Multiply 2 by negative 1 over 144x squared, we have negative 1 over 72x squared, and 2 multiplied by negative 5 over 5,184x cubed, we have negative 5 over 2,592 x cubed. Now, the first 4 terms of these examples are 2 minus 1 over 6x minus 1 over 72x squared minus 5 over 2,592x cubed plus dot dot dot. Okay. Now, for the last example, we'll try this. We have 1 over 2 plus x. So for this example, we have a fraction given equation. So the first thing we need to do is to rewrite the denominator into the proper form of the binomial series. So we have 1 over 2 times 1 plus 1/2 x. So, for the next step, we have to bring 1 plus 1/2 x to the top. So, we have 1/2 multiplied by 1 plus 1/2 x raised to negative 1. So, plug it in the general form. We have 1/2. The summation of 1/2 x raised to n as n goes from 0 to infinity. Index k to n, we have k, which is negative 1. Now, using the example, the formula, 1 plus kx plus k times k minus 1 over 2 factorial multiplied by x squared plus k times k minus 1 times k minus 2 over 3 factorial times x cubed plus dot dot dot. So we have 1/2 multiplied by 1 plus over k negative 1. The value of our x, we have 1/2 x plus negative 1. K minus 1, we have negative 2 over 2 factorial multiplied by 1/2 x squared plus negative 1. K minus 1, we have negative 2. For the k minus 2, we have negative 3 over 3 factorial multiplied by 1/2 x cubed. So we have here, copied again the 1/2 multiplied by 1 minus 1/2 x plus 1/4 x squared minus 1 over 8 x cubed plus dot dot dot. So 1/2 multiplied by 1, we have 1/2 minus 1 over 4x plus 1 over 8x squared plus 1 over 16x cubed plus dot dot dot. So the first 4 terms for this example is 1/2 minus 1/4 x plus 1 8x squared minus 1 over 16x cubed plus dot dot dot. So that's it. I hope you learned a lot from this lesson. Thank you for watching.